Okay, so what I want to take you through now is really the anatomy of a classic three-tier architecture for the LAN. Now, these three-tier architectures have been around for years. They're well established, well understood, and if you go to any large campus, large enterprise, even a large branch of a large company, you're going to see the various infrastructure devices deployed using this classic three-tier architecture. Now, after this, I'm going to take you through a variation on the three-tier by collapsing one of the tiers, and we'll have a look at the classic collapsed backbone, a two-tier variation as used by mid-market or the smaller kind of enterprise environments for reasons that we'll explore later. Now, to start off with, ready prepared, I have the access layer, and the clues in the name. The access layer is a series of boxes. These will be switches, typically switches, and these boxes are there to provide what? Access. So, access to wireless access points, access to users who are wired in, and any other kind of devices at the edge, at the access edge. Now, currently, I've got a very simple illustration here. I've just got 4 boxes, but in reality, I could have 400 of these boxes distributed throughout the enterprise campus. Now, we've got no connectivity as such, so let's start to build some connectivity by bringing in the next layer of this three-tier hierarchy. The next layer is sometimes referred to as the aggregation layer or the distribution layer. Now, aggregation, I'll just mark it up as AGG for our purposes here, otherwise I'm going to run out of space. The aggregation layer is there to aggregate traffic from the access layer, hence the name. So let's put some aggregation layer boxes in place. Now, these boxes tend to be higher performance boxes because they have to take the aggregate bandwidth from the access layer. The more access layer switches you have, typically the more powerful aggregation switches or boxes you're going to be using. Let's get some connectivity in place. Now, I'll have an uplink from the access to the aggregation. And for redundancy, I'll have another uplink. So we have this concept of dual uplinks. And I'll do this from each of my access layer devices, my access layer switches. Notice what I'm doing here. I'm building connectivity from the access to the aggregation, but I'm also considering redundancy. So there we are. Now, what have we got? We've got the access layer, we have the aggregation layer, but hold on a moment. We've also got something else that's appearing. These are referred to as building blocks. Building blocks are defined blocks of switches undertaking the job of access to the users and user devices, and then boxes that provide aggregation of the uplink traffic. Now, I also mentioned that the aggregation layer is sometimes referred to as the distribution layer. So I'll just mark that as DIST''N. Why distribution? Well, think about it. If I want to go from this box here to this box here, my traffic travels up to the aggregation where it is distributed out to wherever it needs to go. In this case, another access layer switch. Maybe we have a user here on the first switch wanting to connect to a device or a user on the other switch. So the job of the aggregation layer in a typical three-tier hierarchy is quite an important job. It typically reflects the policies of the business about what traffic should go to where, what communities of users, of devices are allowed to share resources from other communities and other devices. And that means typically at the distribution, we're not just aggregating the bandwidth, but we're implementing some distribution policy. And I'm going to put a little circle with an X to denote intelligent processes, typically routing processes, to make those routing decisions how to distribute from one point of access to another point of access. So not only are these distribution layer devices having to be sized to accommodate all the traffic from the access layer, so they need to be pretty beefy, they also need to be pretty beefy in terms of their intelligence. They will typically be running routing protocols in order to be able to handle traffic from one point of access being routed by policy to another point of access. So far, so good. Now, I've got, 2 building blocks made up in this simple example just for switches. Remember, I could have 40 access layer switches. I could have 400, 4,000. And I will typically organize these in a whole series of building blocks. As I say, we've just got 2 shown here, but I could have 20, I could have 200 building blocks for a very sizable campus deployment. Now, to link all of these building blocks together, yes, you've guessed it, we have the third tier. Now, the third tier is sometimes referred to as the core, but most commonly referred to as the backbone. And I've got to say, the main purpose of the core or the backbone is pedal to the metal. Generally, the core or the backbone is fairly dumb. Its purpose is to take large amounts of traffic from one building block and get it across to other building blocks based, again, on policy. Remember, we have the policy implemented at the distribution layer. So we can go from one point of access to another point of access, but equally have a policy to say, at that point of access, is it allowed out over, yes, the core. So I'm putting in 2 big core switches. Again, although they're not necessarily as smart as the distribution layer, they probably will have some kind of routing function as well. And again, for the purposes of redundancy, I link my distribution layer devices in a redundant topology to my core devices. And here we have 3-tier. Access to provide access, uplinks to aggregation to provide some kind of distribution policy, and then out across the campus courtesy of the backbone or the core. Now from here, we could also route out to the outside world, namely the wide area network. So that's probably another good reason why these core devices provide some kind of routing service. Or they may simply route to an edge router that will then permit or deny traffic passing to the outside world. And that edge router is probably going to be a firewall. And looking at a typical large enterprise, it's going to be a serious piece of kit. What I hear you say, is there an alternative approach? Well, there is. And this is what I want to move on to next, namely the collapsed backbone. Okay, so here we are. As you can see, the diagram's missing a piece, a core piece, no less. What I'm showing you here is what is the classic 2-tier architecture. And this is favored by the smaller businesses, more mid-market businesses and enterprises, where maybe they haven't got quite so many of these building blocks. You know, in the 3-tier, we could have gone to many hundreds of building blocks, all connected to a common core of high performance and very expensive switching technology. What we're doing here, we haven't actually got rid of the core, but we've collapsed the core functionality into the aggregation or distribution layer. And the way we do this is quite simple. We just have a series of wires connecting each distribution layer device. We may also have some further interconnections between those distribution layer devices. Effectively, the backbone is still here. Clearly, it's still here, but the backbone is now effectively the cable interconnects between those aggregation or distribution layer switches. Why do this? Well, to be honest, it's likely to be cost. This is a lot cheaper deployment. Yes, you're compromising in terms of redundancy, possibly compromising in terms of performance. But then again, it's aimed at a different market. This is aimed at the mid-market or the smaller enterprise. The performance of that backbone is still all about getting traffic from one building block to another building block and potentially also out to the WAN. But that responsibility is now on these distribution layer devices. The distribution or aggregation layer devices are performing a dual role. Yes, aggregation and distribution, but also backbone functionality as well. The benefit? Cost. This is cheaper. And by the way, this is very common.